Hello student, let us solve one more problem on finding Fourier series. Obtain the Fourier series for the function f of x equals to minus pi in minus pi less than x less than 0, in 0 less than x less than pi. Hence deduce that the sum of the reciprocal squares of the odd integers is equal to pi square by 8. Okay, here we have two parts of the question. First part is to find the Fourier series for the given function. Next, we need to deduce the obtained series to reciprocal of the squares of the odd integers is equal to pi square by 8. This we will see later. First, let us find Fourier series for the function. Okay, to find the Fourier series for the function, we need to check the even and odd nature of the given function. Let us consider this function pi of x equals to minus pi, psi of x equals to x. Since the interval is minus pi to pi, we need to check the even and odd nature of the given function by substituting x equals to minus x. That is pi of x equals to, if you substitute here, there is no, in pi of x you can see, we need to check even and odd nature. If two functions given like this, we need to check pi of minus x equals to, if pi of x minus x equals to psi of x, then it is even. If pi of minus x equals to minus psi of x, then it is odd. We can observe here there is no x term in the pi of function, right? Therefore, the given function neither even nor odd. You can observe here pi of x minus x not equals to psi of x, pi of minus x not equals to minus psi of x. It means the given function neither even nor odd. Okay, in this case what we have to do is, if the function is neither even nor odd, then we need to find all the Fourier coefficients and constant term. That is, we need to find a0, an and bn. If it is a even function, bn coefficient becomes 0. If it is odd function, that is given function is odd nature, then a0 and an terms becomes, coefficients becomes 0. But here the given function neither even nor odd, therefore we need to find all the coefficients, and by using those coefficients we need to find the Fourier series. Okay, the Fourier series for f of x having period 2 pi is over the interval minus pi comma pi is given by f of x equals to a0 by 2 plus summation n equals to 1 to infinity en cos nx plus summation n equals to 1 to infinity bn sin nx. Let us take it as equation 1. Now a0 is equals to 1 by pi integration minus pi to pi f of x dx. These are the Euler's formulae. You can see here a0 an. In this case this becomes 1 by pi. Remember that is 1 by pi. a0 is equals to 1 by pi minus pi to pi f of x dx. And minus pi to pi means here we have two functions, 1 by pi, because my interval is minus to pi, limits are minus pi to pi, but for minus pi to pi we have two functions. Therefore, we need to write given f of x like this. Well, I am just rewriting the function 1 by pi minus pi to 0 f of x dx plus, once again I am rewriting that one, 0 to pi f of x dx like this. 1 by pi into bracket minus pi to 0, in that interval function f of x is minus pi into dx plus integration 0 to pi. In that 0 to pi the function is x, therefore x into dx. Now we need to integrate these terms. 1 by pi into bracket minus pi x, that is integration of pi into 1, that is x, minus pi to 0 plus integration of x is x square by 2, 0 to pi. Next, substituting the limits, 1 by pi into bracket minus pi into 0 minus of minus pi plus 1 by 2. This 1 by 2 into pi square minus 0. Next simplifying 1 by pi into bracket minus pi into pi, that is pi into pi plus pi minus 1 pi square by 2. Next taking the LCM and simplifying. Here you can observe minus pi square plus pi square by 2, that is taking the LCM is minus 2 pi square plus pi square by 2. 1 by pi into bracket minus pi square by 2. Here pi 1 pi cancels. We have a naught is equals to minus pi by 2. Next en. En is equals to 1 by pi x into cos nx dx. Again writing in this form 1 by pi into bracket minus pi to pi minus pi to 0. In that interval function f of x minus pi cos nx dx plus integration 0 to pi. In this interval f of x is x into cos nx dx. Next we need to integrate the second term by applying the Bernoulli's rule. 1 by pi into bracket minus pi into integration of cos nx is sin nx by integration of cos nx is sin nx by n between the limits minus pi to 0 plus here we need to apply the Bernoulli's rule. X into cos nx is sin nx by n 0 to pi minus 1 derivative of x is 1 into this 1 by n into integration of sin nx is minus cos nx by n. 1 into 1 by n into minus cos nx by n between the limits 0 to pi. Since sin n pi and sin 0 are 0, the first and second term vanish. n is equals to 1 by pi into bracket 0 plus 0 plus cos nx by n square 0 to pi. Next 1 by n square taking outside 1 upon pi n square into cos nx 0 to pi. 1 upon pi n square into applying the limits cos n pi minus cos n into 0. Cos n pi is minus 1 raised to n. Cos n into 0 is cos 0, that is 1. Therefore n is equals to pi n square into minus 1 raised to n minus 1. Taking minus common from this bracket, n is equals to minus 1 upon pi n square into bracket 1 minus of minus 1 raised to n. This is n. Next bn is equals to 1 by pi integration minus pi to pi f of x into sin nx dx. That is equals to 1 by pi into bracket minus pi to 0 minus pi into sin nx dx plus 0 to pi x into sin nx dx. Next integrating 1 by pi into bracket minus pi into integration of sin nx is minus cos nx by n minus pi to 0 plus here applying the Bernoulli's rule x into integration of sin nx dx minus d by dx of x into integration of sin nx dx into dx between the limits 0 to pi. 1 by pi into this minus into minus plus pi cos nx by n minus pi to 0 plus x into integration of sin nx is minus cos nx by n minus 1 into integration of sin nx is minus cos nx by n into dx 0 to pi. 1 by pi into pi by n into this pi by n cos nx minus pi to 0 plus minus 1 by n into x cos nx 0 to pi plus minus 1 by n minus into minus plus 1 by n into integration of cos nx is sin nx by n into dx 0 to pi. Since sin n pi and sin 0 are 0, therefore the third term becomes 0. We have the second term. First term 1 by pi into bracket pi by n cos n into 0 minus cos n into minus pi minus 1 by n into pi into cos n pi minus x here pi into cos n pi x 0 into cos n into 0, that is 0 only. This term becomes 0. 1 by pi into bracket pi by n into cos n into 0 is cos 0. Cos 0 is 1 minus cos of minus n pi is cos n pi only minus pi by n into cos n pi plus 0. This term 0. Next Here taking pi by n common. 1 by pi into bracket pi by n into 1 minus cos n pi minus cos n pi. Pi cancel. 1 by n into bracket 1 minus cos n pi minus cos n pi is minus 2 cos n pi. That is 1 by n into bracket 1 minus 2 cos n pi. Bn is equals to 1 by n into bracket 1 minus of 2 into cos n pi is minus 1 raised to n. Okay. Substituting the values of en and bn in equation 1, we have f of x equals to minus pi by 2 upon 2 plus summation n equals to 1 to infinity minus 1 upon pi n square, that is en value. 1 minus of minus 1 raised to n cos nx plus summation n equals to 1 to infinity 1 by n into bracket 1 minus of 2 into minus 1 raised to n sin nx, or minus pi by 4 plus summation n to 1 n equals to 1 to infinity minus 1 upon pi n square into bracket 1 minus of minus 1 raised to n cos nx plus summation n equals to 1 to infinity 1 by n into 1 minus of 2 into minus 1 raised to n sin nx. This is required Fourier series. That is one part of the solution. Next go for the second part of the solution. Okay. To deduce the required series, let us put x equals to 0 in the obtained Fourier series. In the obtained Fourier series, we are putting x equals to 0. That is f of 0 equals to 1 by 2. F of 0 plus means f of 0, that is nothing but 1 by 2 into bracket f of 0 plus f of 0 minus. That we can write it as 1 by 2 into bracket 0 plus minus pi, because we have two functions, that is x and minus pi. X becomes 0 and another one is minus pi only, that is equals to minus pi by 2. That is f of 0 becomes minus pi by 2. Hence minus pi by 2 is equals to minus pi by 4 plus summation n equals to 1 to infinity minus 1 upon pi into n square into bracket 1 minus of minus 1 raised to n cos n into 0 plus summation n equals to 1 to infinity 1 by n into bracket 1 minus of 2 into minus 1 raised to n sin n into 0. Sin 0, this becomes sin 0 is 0. Therefore, this term becomes 0. Next, cos n into 0 is cos 0 is 1. Therefore, minus pi by 2, transferring this term to LHS, that is plus pi by 4, that is equal to summation n equals to 1 to infinity minus 1 upon pi n square into bracket 1 minus of minus 1 raised to n into 1, that is cos 0 is 1 plus 0. Next, taking LCM here, that is minus 2 pi plus pi upon 4 minus 1 by pi outside the summation minus 1 by pi into summation n equals to 1 to infinity 1 by n square into bracket 1 minus of minus 1 raised to n. Or this becomes minus pi by 4 and minus 1 by pi, here it is in the form of product, transferring minus 1 by pi to LHS, this becomes minus pi. Minus pi by 4 into minus pi is equals to summation n equals to 1 to infinity 1 by n square into bracket 1 minus of minus 1 raised to n. That is pi square by 4 equals to summation n equals to 1 to infinity 1 by n square into bracket 1 minus of minus 1 raised to n. Next, we need to find the value of this one. But 1 minus of minus 1 raised to n, that is 0 when n is even. 1 minus of minus 1 raised to n value is 2 when n is odd. Therefore, taking n values odd, by taking n as a odd values, we are substituting the value of this term is 2. Hence, pi square by 4 equals to summation n equals to 135 up to infinity 1 by n square into 2. Pi square by this 2 transferring to LHS, that is pi square by 2 into 4, that is equals to, next substituting n equals to 135 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus so on. That is equal to pi square by 8 is equals to 1 by 1 square plus 1 upon 3 square plus 1 upon 5 square plus so on. That is, they asked reciprocal squares of the odd integers. reciprocal squares of the odd integers is equals to pi square by 8. They are asked to deduce this form. Reciprocal squares of the odd integers, nothing but this one, reciprocal of the odd integers, squares of the odd integers. Okay, this is the required answer.